Welcome to the video lecture on signals and systems. In this video, we will be discussing about analysis of DT systems. We will learn how to calculate the total response. So first of all, what is total response? Total response is nothing but zero input response plus zero state response. So what is the zero input response? So zero input response is nothing but the response due to the initial conditions alone. And we fix the initial conditions alone while the input we will fix it as 0. So that is called as a zero input response. In case of zero state response, this is the response due to input alone, in which case the initial conditions are assumed to be 0. So that is why this is called as zero state response. And total response is nothing but zero input response plus the zero state response. We have an example here. Y of n plus 5 y of n minus 1 plus 6 y of n minus 2 is equal to x of n minus 1 plus 2x of n, where x of n is equal to u of n. The initial conditions are y of minus 1 is equal to 1 and y of minus 2 is equal to 0. We will have to find the zero input response, zero state response, and hence the total response. So first of all, we will calculate the zero input response. So what is zero input response? We will fix the input as 0, but while we apply Z transform, we will consider the initial conditions. So considering the initial condition, what is the rule to apply Z transform? Y of n on Z transform will become y of z. Considering initial condition, we are applying the Z transform to y of n minus 1. So it becomes Z inverse y of z plus y of minus 1. Similarly, considering initial conditions, y of n minus 2 on Z transform will give you z power minus 2 y of z plus z inverse y of minus 1 plus y of minus 2. Y of minus 1 and y of minus 2 values are already provided to you in the question. So just substitute the values and we get y of z plus 5 z inverse y of z plus 5 y of minus 1 plus 6 z power minus 2 y of z plus 6 z inverse y of minus 1 plus 6 y of minus 2 equal to 0. So how did we get this equation? We have substituted y of n minus 1, y of n minus 2 in the difference equation whatever is provided in the question to us. So we will solve this particular equation. So how do you solve? We have y of minus 1 and y of minus 2, right? So those two values we can get it from the question. And solve this entire expression for y of z because we need to calculate y of n now. So we get 1 minus 5 z inverse plus 6 z power minus 2 y of z plus 5 plus 6 z inverse equal to 0. Now we convert this to y of z by z format and we get minus of 5z plus 6 by z minus 2 z minus 3. So now we'll have to take partial fractions. So while we take partial fractions, we get a1 by z plus 2 plus a2 by z plus 3. So we will substitute z is equal to minus 2 to get a1, z is equal to minus 3 to get a2. So the a1 and a2 values are a1 is equal to 4 and a2 is equals to minus 9. So just substitute a1, a2 value here. We get y of z is equal to 4z by z minus 2 minus 9z by z plus 3. We have already cross multiplied the z to the numerator of the other side. So next step we will have to take inverse Z transform. So how do you take inverse Z transform? If your signal is of the form a power n u of n, then that on Z transform gives you z by z minus a. So what we have here is z by z plus 2, z by z plus 3. We will have to take the inverse here. So when we take inverse here, we get y of n is equal to 4 minus 2 power n minus 9 minus 3 whole power n the whole u of n. For denoting purpose, we have mentioned this as y of 0i of n, that is zero input response. For zero state response, we will mention it as y 0s of n. So next is zero state response. For zero state response, what we'll have to do, we will consider the input, but we will assume the initial conditions as 0. We will also assume x of minus 1 to be 0. So here when we take Z transform, we have your a difference equation in your question, right? So when you apply Z transform to your difference equation, direct Z transform you can apply. Y of n on Z transform will give you Y of Z. Y of n minus 1 on Z transform will give you Z inverse Y of Z. Y of n minus 2 on Z transform will give you Z power minus 2 Y of Z. This so is the case for x of n minus 1 and x of n minus 2. We are not going to consider the initial conditions, so you need not apply the initial condition rule here. But we will consider the input here. So we get 1 plus 5 Z inverse plus 6 Z power minus 2 Y of Z equal to Z inverse x of Z minus x of minus 1 plus 2 x of Z. So what we'll have to do here is we will have to apply x of Z here. So x of Z from the given question is Z by Z minus 1. X of n is already given to you in the question. So from that we have taken x of Z. So now you'll have to solve this entire expression for y of Z. For partial fraction purpose, we are making it as y of Z by Z. So this Z, we already have it here. We have Z square, right? So one Z we will multiply to the numerator on the other side, while the other Z we will keep it here. Y of Z by Z is equal to Z into 2Z plus 1 by Z minus 1, Z plus 2, Z plus 3. Now, by partial fraction rule, this becomes A1 by Z minus 1 plus A2 by Z plus 2 plus A3 by Z plus 3. You can even have it as A by B by C by as you wish. So you have to substitute Z is equal to 1 to find out A1, Z is equal to minus 2 to find out A2, Z is equal to minus 3 to find out A3. Your A1 value is 1 by 4, A2 value is minus 2, A3 value is 15 by 4. So next step, we will have to substitute A1, A2, A3 respectively in the previous equation. So when you substitute, what do you get? Y of Z equal to 1 by 4 Z by Z minus 1 minus 2 Z by Z plus 2 plus 15 by 4 Z by Z plus 3. Remember, we have already multiplied the Z to the numerator. We initially had it as Y of Z by Z and multiplied the Z to the numerator of the other side here. So next step is we'll have to take inverse Z transform. So any signal of the form a power n u of n on Z transform will give you Z by Z minus a. So we have a Z by Z minus 1 in the first term. So this becomes 1 power n u of n. So simply we have written it as 1 by 4. Then we have in the second term 2Z by Z plus 2, that is Z by Z plus 2. So this is minus 2 power n u of n. So second term we have minus 2 power n u of n. Then the third term we have Z by Z plus 3. So what is this? 3 power n u of n, minus 3 power n u of n. So your third term you have it as 15 by 4 minus 3 power n. We have taken u of n as common here. Now the last step, we will have to find the total response. So what is total response? Zero state response plus the zero input response. So because this particular equation we have found out is that belongs to the zero state response, I mentioned it as y0s of n. So what is y of n here? Your total response, zero state response plus zero input response. That is y0s of n plus y0i of n. So I have substituted the zero state response first. The first three terms belongs to zero state response and the last two terms belongs to the zero input response. Now we'll have to add all these together. So look at here, we have two terms of the form minus 2 power n. So here we have minus 2 power n. And we have 4 minus 2 power n. So minus 2 power n is common to both terms. Apart from that, you have minus 2 here as coefficient. You have 4 here as coefficient. So what is minus 2 plus 4? It is plus 2. So look at here, your second term 2 minus 2 power n. And this 1 by 4 is a constant term which is left alone. So I have copied it just like that. And we have two terms of the format minus 3 power n. So look at both the coefficients, 15 by 4 minus 9. So what is 15 by 4 minus 9? Minus 29 by 4. So combined, we write your final total response y of n as 1 by 4 plus 2 to minus 2 power n minus 21 by 4 minus 3 power n u of n, the whole u of n. So this is how you will have to find out a total response. You will have to solve the problems on total response. Thank you.